FixerBot says.
Welcome. Stream starts in 5 minutes.
Gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unroll secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
T-minus 4 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unroll secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow. Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high
Stream about to start. 1 minute left.
expectations, gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unroll secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
welcome in. So, I was just watching True Sex, talk for now. So that's one late. So they had a few technical difficulties there. But it worked well then. I think they had a glitchy switch. They needed a restart. It happens to everyone, right? So, let's see. I just hopped back to where we were, right? So we check into pwntools. Actually, I couldn't avoid continuing a bit yesterday, and yeah, it's like a bit outdated. Let's start the little Kali. It's actually just logging in. So so this is what we had. Or rather, what I got. I even opened a new one. So we were in RAR2 here. Let's see. Yeah, I guess the last run script is a bit up. Here. No, not even there. Here. Right, so we were running R2, and I was thinking I'd get data from this, as we did when getting the EIP. But I'm thinking I have a better solution, and it's already done. We're using IO core file. And so far I've just printed out contents of it. And it's not working. I don't have checked totally on how we use the IO core file read function. So that's what we need to do next. But I'll just show you what I changed since last time. So I've commented out the start of let's see. Here is where we start R2. So this line is not even changed since before. I was thinking of adding A there too. Because A. That's why we added the line, because it's already up here at the top. So this is a script to automatically do a buffer overflow from a Linux SUID executable. That's what we're going for. So just to go quickly through it, first we're going to use R2 for parts. This is executable name. Do I still have the box up? Yeah, so this is the box we're doing, but we're not really doing it quickly. We're just using it to have something to test on while we're doing it too, Not as quick as possible. Learn as much as possible. That's the goal. So, yeah, so we're running the executable with increasing size arguments, fuzzing it, seeing where will it crash, right? And when it crashes, we're saving this length to a crash length just to make it more readable. When we later here run generating a non-repeating string, cyclic crash length. It's kind of obvious, right? What it was. So this will generate the non-cyclic string. Then we have running executable in R2 will generate the string. So we start a process here with pwntools. The path to R2 and a nice, let's see how nice it shows us the values here. And then the arguments, D for debug. And then we have executable name is validate. And then we have the string that is made from the crashling cyclic as the argument to this executable. Because that's how R2 works. You send the executable name and its argument just after it. And it's a very simple executable. Yeah, I don't have to show the code again. But we got C code from Ghidra. Let's see here. Yeah, so to start R2, we need to send it DC. That's a command to run the executable after we have loaded in. There might be an option. I didn't find one though. And this will just put that in the buffer until it's ready to get some input. And then we just repeat through the lines of the output until we find a signal 11, the buffer overflow. As we know, this is a buffer overflow binary. We know it will happen at some point if we just keep increasing the input size forever. And this is forever. We can also set the step size here. If we're like, oh, this is going slow, let's put 100 there instead, you know, or 50, you know, whatever. Yeah, so when it crashes, and we're quitting out of R2 here. But we also save from this line where it says signal 11. First we write the full line, then we find on what position is the address, because this is how the output looks like from R2. And then we skip past these 5 letters here, and we get the next 10, which happen to be the address. So 0x, I think, and yeah, 0x and the numbers in hex. And then we print it also in hex format, though we make it an int first, so it's a number. Then we hop out of the infinite loop, and now we have the EIP crash address. So finding, or rather, we have the string, the part of the string, the value we get here. Maybe we shouldn't call it crash address, but crash string. Yeah, let's do that, because this is not clear. When I was reading it myself, I said the wrong words because of this. So crash string is better. So crash string, and let's change this to, it's still a hex number, right? And this wants this input, and that's why we have it in this format, because cyclic find likes it. I'm kind of thinking why I made it an int. Doesn't it want, yeah, it wants a number. It just, you usually write the hex here. That's why I'm making it an int. Yeah. So we need to change this one too, of course. Otherwise it won't work. So making it better as we read it, of course, right? And EIP position is a crash position. It's a position where if we overwrite this position when we send the input in, and if we write an address at this position, it will jump there. And that's what we want. Then we generate shellcode for a series binary. And we want to be the user 1001 on this machine. That's the one we want to switch to. And it is also the owner of the binary. So we need this number as we create this. We say this is an i386 architecture, 32 bits. Then we use shellcrafts. This is generate strings, assembler code strings, and we can output them here if we uncomment this. So we get the assembler code for set reUID to this, to change our ID to this one, and also to get a shell. Just start normal shell as this user. This is no networking anything in this one, it's a very simple one. Then we have, we create shellcode from this assembler string. Shell i386. Maybe I should change the name of the variable to shellcode assembler code. Yeah, I like having good variable names, so it's easy to read it even if you don't know what it is before. So shellcode assembler code. So I think that is more obvious, is it? Instead of shell i386, it's kind of like not saying anything. Shellcode assembler code into shellcode with asm. It's assembling this assembler code into shellcode. Then we print the shellcode as hex, so it's easy to read. And we also check the length of it, because it's nice to know how long it is. Then we're going to test for bad characters, and this is what we're working on right now. I just realized I have not made a get save on this. If we do, we can just delete this. Yeah, and this is in my public Obsidian notes. So we can just update quickly my Obsidian. Let's do that. So before we get started on modifying it, we can just delete some stuff. It's still saved in get, right? So we need d colon. I was gonna type more there. So what is it? It is Obsidian. Public. And I'm like, should I do ls? Yeah, the right directory, so let's just do git status and see how many files we have changed. Quite a few. So let's add it. Adding all the files that have been modified. Do I dare to start typing? I don't do this very often, as it's not a code repo, but knowledge stuff. But it was time, definitely. Updates. I usually just do updates and the date. So 2025. 29. It's almost February already. How did it happen? I don't know. There. So let's check status again. So these are separate repos, that's why they're red. So let's just push it and we're done. Might as well push it. So now it's updated on my GitHub. So let's do GitHub. There. I should change that one. So this repo is called Obsidian Public. So now we can just delete this because it's saved. Yeah, so I made a new temp and everything. All of this is old. I'm not gonna use this. And also this is built upon... I'm just checking these lines here. Send line. Yeah, right. Let's... read it before I delete it. Read all input. px. Right, these are the px commands. Yeah. Did I put those in the notes? Because those were kind of nice. So... the alternative way worked out better, so I'm just gonna go and grab from the last output here these two lines. Though the code was kind of nicer there. Because it actually says the mass of calculating these, right? I trust my brain to remember it. So, to say it quickly, this is the length we want to see, and this is the position, and we're going back here to see our embedded data. This should really be 200, and I updated that in the code later, but I don't know if I run it. Since we're going back here, we're adding to how much data we want to see. Here we just want to see the length of the bad shards, and here we see the length of the bad shards plus this number. So that's why they are like that. And the PXA is just the R2 command to show memory, and this is the position. And yesterday we learned that we can put the length in front of it there. I think I got it off some like question thingy finally. Didn't find it in the R2 stuff. So we actually calculating the address length, and this is not just relevant for this. So I'm thinking we'll put this one further up. As this was just a temporary thing until now, I didn't move it up. So the number of bits and stuff. Yeah. So these two we want also higher up. And we need, of course, the bit set before we divide it by 8, right? So let's cut all of those and put them at the top where we have variables we might want to change. So we might want to change this. And instead of putting this just as a constant, I thought, why not use this one? Right? And instead of just typing BBBB, for example. That's where it's used. So here we have address length times B. We have the cyclic string, we have this, and then we have this. Then we actually use the cyclic string to find... Well, we didn't do that. But we could use that to find our place in memory too, but we're actually currently using just SP here. Yeah. And this is where I'm at. This is where I'm at checking it out and seeing what can I do. What can I write before here, read the first argument. What will be an acceptable value here? So let's try something totally off, right? Like 0. It wants a number or it'll complain. So if we just instead here replace the stack data, and this is just testing. We're not going for the actual data. We already have the actual data. It is over here. So here we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the bad shards test here. A, B, C, D. Yeah, so maybe we should have like output 16 of these and then make a new line. That did make it easier to read if we wanted to. Though we're going for a programmatic way of checking it, of course. Let's see, where do we end up? 8, A, C, E, F. So here, this is the data, and we can cut off different bits of it, right? We're not using R2 anymore, so we can do using core file .read, though that's probably too much info for there. Testing for bad characters is enough. we're doing just with pwntools now, so we don't have to say anything extra. So yeah, the very off here, we can delete that. We're testing it now. So I did the len of my input for the bad chars, which is called use chars. So we have all characters. We remove our bad characters, which happen to be F from the logic of the executable, because it fails and aborts its loop to copy all the characters if it gets F. So we know that. That's why it's also a character and not a hex digit. Yeah, and then it compares, it removes from all chars the bad chars. And this is when I'm getting annoyed at code, because it keeps popping these up. I want a longer delay than this. If someone happens to know how to do that, I'm happy. I think I even asked ChatGPT for it, and it didn't have any answer to me. And I checked some settings. I should do that, but not now. Yeah, so let's, instead of giving it a SP that is a number, we're gonna do like 0 here. And we can do like 100 here. So let's read address 0. What will it say, you know? What is the... Will it try and read and get a access problem? That's what I'm assuming. Yeah, so we got error, address 0x64 is not contained in core file. And this is, yeah, it's actually making a file there. Though everything is files, right? Traceback most recent. Oh, lost. I'm just reading it. Why should I do that? Yeah, so 0 was not a good thing, but I'm curious why it says 64 and not 0. So let's hop to... I want to know more about core file, and obviously we can do SP, right? Because then we get the SP, ESP in this case. And that's what we used for... Yeah, well, it was there. But let's pull up the notes. So this is where I got... Yeah, we can close that one, because this is doing it manually, right? And this is where I got Shellcraft from an older Google, and that's why I thought, well, let's do it, right? Learn pwntools. And this is my article that we're going to add to a lot for finding the systematic. And this is in BrainPan, so this is in the box we're doing notes. And this is where I'll put the script when it's finished. So let's actually remove it. It looks a bit odd to have a not finished script here. Whatever. Don't change it now. It's already on GitHub, right? I'm a bit hungry. That's why I'm pausing. Maybe I should get something. Or should I wait an hour? I'll get a glass of yogurt and continue. Yeah, so these are merging into each other now because we're making the script. So what I wanted to show was actually on here. What I wanted to go back to was this. Right? And here we also have FC offset. That's not what I was going for here. Here's the output of the script.
Says, hi.
Hi, welcome in. So we're making a script to make an automatic buffer overflow of a SUID binary on Linux that is owned by someone we want to be, and that is user ID 1001. And playing around with this, trying to learn better pwntools. So I'm actually going to Google now and see if IO core file, if we can find actual IO core file read. I want more information on that, and we'll try and do that, make that, of course. Let's do pwn. There. So here's the file. This is probably open already. Yeah, this is this. But I want more. I want more information, because we can give it an address here, and the length, and we know this. But what addresses can we use, right? What is the lowest address that it will accept? What if we use like the base address of the executable? We can get that. Let's try that one. So we just tried with 0 here, right? So let's say we want to read 100 characters, but now we want to read from. So what am I doing with the? So I have a elf. This was the first with pwntools. So we're getting the information about the elf file here. Elf file name. After we've done this, we can get its base address here. e.address. So actually it is elf filename dot address. I'm thinking we can probably do address on just what we already have too. So we're running the process, and then we have IO. So IO.address might work. Let's try IO.address. Oops, caps. So let's see. I don't trust the squigglies. Yeah, it disappeared suddenly. It's very slow on my Kali VM, updating the squigglies. So this one, I just started this one because I didn't wanna. I was continuing off the stream history. So this is when I made this bit. We can close out. We don't need to. Actually, I'm gonna clear this one too. And I started also because we had our 2 up already. Let's clear this. We're fresh and new. And this is the script. So, IO address. What does it say about it? Process has no attribute, so we'll have to get it the other way. So let's just copy from here. Elf. Actually, I can type 3 letters, right? Elf. So.
Fixerbot says,
New follower 0 Picard 0. Less than 3.
Thank you for following. Welcome in. So let's see here. Executable. I'll copy that. And there. Yeah, I could copy from the process one. So if we check this one's address, and we are just doing errors, so it shouldn't pop up a lot of output, which it does as default. Yeah, we could run the elf info. So this one, pwntools is kind of cool. It can do a lot of things. So here I have enabled debug information too. But this is what it writes if you just do this command elf and an executable name without telling it not to.
Zero Picard Zero says. Is that Python?
Yeah, it's Python, and it's a library called pwntools, so it's very cool. It can do all of these things. Let's just disable the debug here for this one. Here, let's comment that line, and we get the default output of this. It can, as you can see, it can disassemble stuff too. So now we don't have debug info. It can. This is what it shows by default when we just elf uppercase a executable name, and then we can get information more. It's Linux. It's i386 32 bits, little onion, and the log level here that I set. The base address is this, and this is what we're going for right now then. And this is just writing random information. Well, in this case, the first 32 bytes on this address. So we can do that easily. Disassembling function, yeah, validate. So it has two functions. This is executable, validate, and it has validate and main. And we don't have to read this because I disassembled the name. Oh, it's I got to see from Gita, and it's very readable. Nice. So if we run this one now, to get back to this, we get this I address didn't exist. So we're gonna have to change it to, where am I? Here, elf executable address. So if I save it, I didn't save it. Now let's see what it says now. It's just running stuff. So now it worked. We need to know where we are. It's too much stuff, too much output. So let's just put an exit here, right? So we know the lost stuff is this. Temp colon is up here. And we need to print it. So yeah, right, so I changed the wrong one. Let's actually undo this. Or let's do this. Copy this line, and I'm just, because I don't know if I changed both. Oh my god. Kinda too money, right? I was thinking it didn't have that long history, like today's history. Yeah, so that's where it was, right? And then I changed. So let's paste that one here, and add the exit here. And let's change this to print instead. So this is Python code, and it is a here from pwn import star. And if you want this in your Kali, then you have to do apt install pwntools, because I tried with pip install in different ways and it didn't work. So now we're printing it, and then we're exiting. So the last bit, let's actually add an empty print here too. It's the quickest way to make it give us some extra space there. So this bit here is the first, and we can see here, elf. This is the first data of the elf. We can read this part of memory. Wish we should, of course, but so what else could we possibly read then? This worked fine. Let's do something else. This is just a random address. I realized I knew another way to get an address from it. But how do I get other addresses? Let's check this out a bit. So the purpose is not to finish the script or finish the box quickly, but to learn as much as possible about pwntools. That's the purpose right now. We could TTS this while I go get yogurt, but I don't think we'll be able to understand much. I mean, you need to see code, right? It's much better. So this is a simple example here. Cyclic. It's running process.
I'm sorry I have to go now. I will come back to your channel another day. Good luck.
Thank you. Have a great day. And thank you for coming. So core. Third tag in payload. Yeah, right. This is what I said about finding. We could use this method too if we wanted to. Part of me wants to do both in the script just to show that it's possible, and part of me wants it to be as efficient as possible, right? And as we have the SP, that is one way. So this one actually exploits the simple one here, and it replaces the return address to win's address. So this is very interesting code too. I don't want to lose this. Maybe we should just put this example in there in the notes. So let's see. Notes. This is not brainpan, this is generally buffer overflow. Let's close a few things here. Oh, web. So I guess this is an example of this, but it's not really an example I did, so it is still an example. But it's pwntools, right? So let's put it here in pwntools Python new note, and we're gonna put the URL in here too, as it's not mine. We can undo all of that because it's already in the right, isn't it, format? No, it's not. So let's do that again. But it's Python. Actually, the first bit is C. So let's just paste it, and then we have there's a new section, and there's a new section, and this is shell, And this is Python, and this is C. So we have a C. Let's just do example and core dump and assert. I need to know how assert works. So we're gonna put this link at the top of the example here. There. And it's now prettier in the notes. Let's just scroll a bit more. Enhances the information available about core file, which is an extension of the ELF format, by permitting extraction of information about the map data segments and the register state. Routers can be asserted directly. Okay, so asserted. Accessed. I don't know why I read exerted, because I was looking for assert. That's why. Our cyclic binding should have been used as the crashing address. Assert pack core IP in payload. So assert. I need to know assert. So Python assert. I don't know what assert is. I feel like, wow, I found something new and cool. Test if a condition returns true. X equals hello. If the condition returns true, then nothing happens. If condition returns false, assertion error is erased.
Passing percussionist says,
So
best viewers on stream boo.
but TTS is a
Remove
bit
the
too
space
quick.
code TDJ5T7.
Assert keyword used when debugging code. So it's not really a thing. It's more like a try this, if it crashes, die. It's like a not a pretty thing. So now I know why I didn't know it, right? I haven't seen anyone use it in code before. If condition returns false, then assertion error is erased. X should be hello. Let's try it, right? So if we run this, my god. We should have run it locally. Invalid syntax. Okay, I get it. Yeah, this is too slow. We can't use this. So we have more knowledge about what it is now. Yeah, this was an image from Undeciphered's course yesterday. Someone put it in chat, so now I'm curious to check that thing out, that book. You can specify a full path. Core file path with core, but you can also access the process core file attribute. Yeah, I've noticed. Looking for stuff that's new. So L from assembly. We could do that too. But I haven't tested it yet. C equals core file, C.registers. We can get the register information here from the core file too. That's nice. So let's test that. Oh gosh. And this is not a cert anymore. That's not an important word in it. That was a Python command I didn't know. So let's do print. So we have io dot core file, and I'm not doing C equals because then we don't remember what the full thing was. That's good, right? So registers. Yeah, this should be it. And I really meant to do this. So we have some more spacing there. It's saved. Let's run it. So we should get the registers at the end now. Oh, we want to p-print that. So here we can see the registers. Just checking the format of the values. They're just normal ints. Okie dokie. So let's I keep hopping to the screen for notes, so let's move the notes over. Core dump. We also have let's put the important stuff here. So we have IO core file registers. All register. Kind of obvious, right? But let's just do it. And let's do this so we don't have to have the squigglies. What else is this using that we can use? Pack core EP and payload. Yeah, so this breaks the whole darn thing if pack core EIP is not in payload. So I'm assuming this is a part of the cyclic string because it's crashed, since it's supposed to crash and it waits till it's finished, right? Run the process once so that it crashes. Okay. It'll need input then to crash. Okay. We can do this one. It can be fun. Core dump, core. But one thing first, right? Crash. Elf crash. Payload equals fit. So fit. Cyclic find core EP. Crash symbols when. So we should be able to do symbols when too. And we pre-printing there automatically, so no. Attribute error name. Attribute error win. Oh, it's because win is one of the functions. So we'll have to do validate, for example. We don't have a win function. No? I thought it was validate. Isn't it validate? Or just on off? Yeah, so it doesn't work like that. It's something off. So they're connecting to elf crash. Right. Oh, okay. Yeah, I got it. It's I'm trying to tab to Kelly, and when I want to switch that way. So this is also the elf executable that here, and I've already done this in this file, so I already have this information. So for functions, and there's also symbols here. There. This is that e symbols function name. So we don't need this. Let's see what else we can find. Yeah, let's actually do what I just did here. IO core file in pprint and see what we get. It might take some time. Main? Didn't I save it? I didn't save it. Sorry for that. It's a bit of a delay there. Okay, so this is interesting. We got the path to the file, right? So let's cat this file. Core dots. Oh, now I'm curious. Ooh, got so many ones. Let's do 8, 2, 8, 2, 0, 2, 1, 1. Oh, they're all here. That's quite a lot of them. And they're taking kind of a lot of space too. So let's actually RM those, but we saw the permissions, right? So let's yeah. So pwntools core dot files. we're at the core file again, but I want to really know more about the files and when they're created, and so let's go back. I'm gonna get a core file for a P. In Python, like I can with pwntools for an elf. Yeah, that's an interesting question. Okay. So the answer 3 years ago was no, at least, but so it is when you run pwntool process that is created. When is core dot created, and let's remove core here. So that's a ChatGPT question. Oh well, let's actually try this. What do you think? Should we give it a chance? I asked one question. Oh, so close sidebar, new chat. So it's made to be similar to ChatGPT, right? In pwntools, the core file is typically created when a process crashes due to segmentation fault. Oh, now I know why it's hopped. Yeah, I need to switch cards. I know. So it's 11, and then try hack me pops up, and we're actually doing this box right now. So, I'm gonna TTS this while I go and get yogurt. And I forgot to put the air thing in. I'm so sorry. You would have had an echo all time. I'm sorry for that. Forgot to remove the echo. So I'll TTS this, and this is how it should work when chat is on.
Fix it says. Test.
There shouldn't be an echo, okay?
The core file is typically created
I'll
when a
get
process
yogurt.
crashes due to a segmentation fault or other fatal errors. The core file contains the memory state of the process at the time of the crash, which can be useful for debugging. When is the core file created? 1. Process crash. The core file is generated when the process crashes due to a fatal error, such as a segmentation fault, bus error, or other signals that terminate the process, example SIGSEG, SIGABRITE. 2. Core dump configuration. The creation of the core file depends on the system's core dump configuration. You can check and configure core dump settings using 1. Ulimit C, check the maximum size of the core file. If it's set to 0, core files won't be generated. 2. Ulimit C unlimited, allow core files of any size to be generated. 3. /proc/sys/kernel/core_pattern, configure the location and naming of core files. 3. Debugging with pwntools. When using pwntools to exploit or debug a binary, if the process crashes, pwntools can automatically load the core file for analysis. For example, Python. Copy. From pwn import asterisk. Hashtag run the binary. P equals process, / vulnerable _binary. P send line, b input _ that _ crashes. P wait _ for _close. Hashtag load the core file. Core equals p core file. Print, core registers, hashtag inspect register values at crash. Keynotes. 1. If the system is not configured to generate core files, pwntools won't be able to load a core file. 2. The core file is created in the current working directory or as specified by the core_pattern configuration. 3. Use core equals p.core file in pwntools to load and analyze the core file after a crash. Let me know if you need further clarification.
So, I almost have to ask the same question in ChatGPT. Almost. Right? So, I was a bit hungry, so I got you some yogurt. Let's well use time, right? Multitasking. So, I'm thinking, do I have tabs I can close? Well, it doesn't matter right now. Let's build an example. So we're learning stuff, that's good. Shellcraft move. Shellcraft move. Ooh, this is nice. Shellcode. BXR1 address. From binary assemble. Shellcode BMA equals address. Yeah, there's so many cool things. We can just put assembly into there, like this too. So if we'd like to change or add instructions, we can do that too, right? Then we have the core file, core hex, core exe address. So now I'm interested again here. Let's see. The core file has exe property, which is a mapping object. Each mapping can be accessed with virtual addresses via subscript, or contents can be examined via the mapping data attribute. So, core exe address. I'm kind of assuming it is the same. Let's see what it is. The core file also has registers which can be accessed directly. And we already use this, so we know that works. But we haven't used core exe address. So, .exe address. Copy that, hop over here and hop to there and just paste it where we were. And then we're gonna run it again. So, I'm sorry for the delay there. 134512640. That was not a lot of information, but we want it to be printed in another way, right? I'm just getting a line. Where do I print an address? Here. This bit here, right? We don't need a p print. We want to just have a normal exe.address. There. I should comment some stuff out because of the delay. Yeah. So if you compare this with this. So that's how we get it, the address. I was trying before with core file io.address, right? So make sure I save it. Meaning we can update this to this. Because it is the same and we don't have to open it again. This goes of course to the nodes, right? Start instead of, yeah. So another way to get the same information that we get here. The question is if we should use base address, because I wanted to make it more friendly. What else can we find? See. So I'm gonna go drive my kid to school in about an hour, a bit more than an hour. So I have to go check if he wants something to eat first. I think he already ate. He made a pizza yesterday. He's 14. And I think he ate half of it, the second half as breakfast. So I don't think he's that hungry, but I'm gonna go check anyway. Yeah, I'm kind of assuming he's full, but you never know with 14-year-olds. He's also kind of big, tall, not a tiny boy. So I'm back, but I'm reorganizing here. And obviously one thing didn't want to be where I temporarily put it there. So there. So I did get some sausages for my kid that I fried yesterday. So I got one for me too. Eating more than yogurt before driving him to school. So I usually sit in the library there while he's at school for 2 hours. Yeah. So actually been doing TCM, is it right? There are summer course, but it's very basic. But it's all of the courses start at very low level, or basic level, I should say, I guess. Right? So that's good for everybody, but if you know some stuff before, it's a bit slow. The core file also has, where is your switch access? On all architectures, yeah, because this doesn't only work on ELF files. So, but most things might. I mean, the ELF only works on ELFs, right? But where does the process work? Oh, very hot. We can also extract this information from the core dump via fault address and signal. Oh, this is so cool. We could use this for the previous one too. Yes. We don't have to use what I'm currently doing. So, I should have looked more, obviously, right? So here, though we'd have a million core files from doing this, I think this way is actually better. Because if we're using pwn's process here and not well, we're using, but R2 is not crashing. So as we're not crashing the program that's done, we're not getting a core done. Because we would get one for every loop, and we would have to restart it. Yeah, this is better. This is better, the way we're doing it. Though, it only crashes once when we reach the point. Yeah, no, we have to rerun it. Yeah. No, that's a crash. Here is the sub-process run, and this is the one I meant to go to. So, this is where we're not using process. So this is where we don't get a lot of core files. Are we getting core files? Anyway. Because it crashes once, right? Let's check it out. So when running this now, how many core files should we get? So it crashes there, it crashes here. I'm like, don't remember what I'm doing. So this is the crash. But are we running it again? Yeah. Of course we are. But have we commented it? Or exited before we do it? I'm like so messy here. Let's, here it is. There. So, of course, since we're reading its core file here, I was just thinking, are we using the old one? Time for energy boost, right? Yeah, so that's good. So we should actually get 2 core files then. That's what I assumed from the start, but I just wanted to, you know. So let's see. We have 3. So if we remove these again and hope that I don't have to type the password with one hand, because that's kind of impossible. So now we have known, and we're running this. And we do LSLA again, and we have 1 core file. Meaning the other crash does not generate a core file we can see, at least. If it does it somewhere else, I don't know how the core files work. I mean, it sounded a bit, what we TTS'd, like they're generated for all crashes, all the time in Linux. Right? But maybe the pwntools just puts them in another place where we can see them easier. And it's quite a lot of data we have there. This will be a lot of stuff, you know. So we can just read it. A nice binary data. We saw L44 there. A lot of core. While I eat, I'll TTS this file, okay? If it ever loads. Alright, let's...
Setting up Linux to produce core files using ulimit to set core file sizes. 1 June 7th, 20242. Knowledge. Business line. Last published date. June 7th, 2024, 11:35 a.m. Problem. How do I set up Linux to produce core files? Information. A core file is created when a program terminates unexpectedly, and can be useful for determining what caused the termination. By default, many Linux distributions do not produce core files when programs crash. This article describes how to override the default. Using ulimit to set core file sizes. Ulimit is a program, included in most Linux distributions, that allows you to specify many file size limits for the shell and all of its subprocesses. For most distributions, the core file size limitation is set to 0 to produce no core files at all. To find out the limit on the system in question, issue the command $ulimitc. If it is set to 0, then no core files are produced. To allow core files to be produced, set a core file size that is not 0. $ulimitc 1000. Or $ulimitc unlimited. The above commands set the core file size to 100 MB or unlimited, respectively. Creating a test core file. To test whether or not a core file can be created, try the following command. Kill $. This command crashes your shell and produces a core file in the current directory or /var/crash. See core files in Linux below. Things to note about ulimit. Ulimit sets shell variables. This means that the limits you set are valid only for that shell and all its subprocesses. If you want to set a limit system-wide, you need to ensure that ulimit sets its variables at startup. Usually it is sufficient to place the command in your _profile, or whatever
Yeah, so we don't
initialization
need to
file
know
is used
more,
by
do
your
we?
shells. Apport core dumps. Linux systems may be running apport to handle core dumps, and this results in the core dump plus other relevant data being stored in /var/crash/. The file name created is composed from the name of the crashed executable and the
Yeah, so
user
I
ID.
assumed there
For
was a
example,
special directory for it.
//usr_team_user1_bin_r23.2_p.
So, we obviously have 0 set, but then pwntools changes this for the current shell session, I guess. For the current command, at least. Scope they're in. Okay, interesting. We're learning stuff about Linux here too that I didn't know. So, I don't want to say how many years I used Linux for, you know? Though not intensely. I'd reveal my age, which is very secret. Extremely, right? You can't just Google my name and get my age. So, that's how it works in Sweden. Nice. We know more things about core files. We know that it's pwntools that sets variables that it is actually generated and set it to the local directory where we're running it. And I don't know if it's executables directory or if it's our current directory. We could test that. Yeah, so we had this core fault address, which made me like, wow, this is nice. Yeah. And also signal, this is cool. Very cool. And 11. So. Where did it say true? Oh, it was a test. Okay. I don't know why it would want that. Crash EIP, I'm assuming, so let's do that. Kinda obvious, the 11, right? Crash signal. It's kinda bad commenting here, right? Oh. On QMO, this is unavailable. instead of accessing a register directly, we can also extract this information from the card and via folder and signal. Will the signal be available in the registers? Then I'm curious. Because I've never thought of that. We could always look at them. We're already looking at them. So the reason I didn't do this in the current one is because we're looking at the data. And this is really what I was looking for when I googled, right? I didn't look for knowing about the things we found. So I was looking for the file format. So I'm kind of glad I clicked the one I did. So I want the exact details of the file format, where what data is, how it works, because I can see there's data here, right? We can see this is the name, the name of the directory, which is current, and also the argument. It says ELF44 here too. Then we have the full path of the executable several times. We have lives 6, twice, 3 times, 4 times, 5 times. Number 2, 2, 3, 4, 5 times. Then we have color FTG command. Now I'm curious to see what binwalk says about these files. Failed X usage. Yeah, here's we have the binary at the start, I guess. That's what we have. We have the ELF first. But what address would I reference? It's not 0, right? Because 0 didn't work. We tried it. So there must be other stuff than just dumping. What would it dump also? So I'm gonna go quick scroll this. Shift page down. This was too funny to just... This is generally memory, right? Maybe there's passwords I have written that you can read from here. Here we have... Oh. Yes, we're still at the very top, right? It's a long file. It's 2 million characters. So we can scroll for a bit. So I can see it moving. But let's go graphical on it. Oopsie. Well, I was just trying to scroll. Touch the other mouse button. We could also do strings, of course. Well, server reacted credential. Where are we now? yeah, maybe I shouldn't waste my time having fun with this. Let's just see what Binwalk says about the what on earth is this file called? Yeah, core. Yeah, it's kind of saying a lot of things. That's nice. So ELF 32-bit LSB core file Intel 386. And now we also have addresses. Unix path. Copyright string. It's really picking up a lot of things here, right? Though we're far from the start of it. I'm of course assuming not a lot of this is our data, right? I'm curious in how this file is created and how all the details are in memory. Let's make a note on Linux core files, right? Because this is basic Linux knowledge that we've gained. So let's put it in Linux. So by Windows, by programming, hi Linux. We have a command, but this is like a basic thingy. Linux core files, I guess. Core files. And I did close the tab where I put the commands we got from here. So let's open it again. I remember it was slow to start. So this is so this is the command ulimit. Command to find current core file size setting. F0, no files will be created. So there. Then we also have path here. Files might be created. Nah, files can be created in var crash. Yeah. Let's put that too in the little thingamadoos. So, and then we have
Honey to Hammore says, hey, I want to start into cybersecurity. Can you guide me how to get in cyber beginner to advance?
Yeah, so what's your pre-knowledge? Do you know much about computers? Do you just know how to surf on the web? Are you a programmer? Do you know like electronics? What's your starting point? Everybody knows something about it already, right? Maybe you're studying something close by, another area. And welcome in. I'll continue searching here. Oh, you know Linux. That's great. That's a very good start. So Kali Linux, you might have heard of. It has so many tools. So I would start looking at try hacking.
And fundamental of network.
Great. Yeah, you know already a lot of things. So let's go to try hack me. This is a site that has a lot of free content. So if we go to learn here, I guess learn. They have a starting thing here, free security you can do. I don't know if all of this is free or not. Cybersecurity 101, and then you have a lot of other paths there that you can do. But you can also click the learning paths. There's lots of different paths. But if you go to search, and we search for room type, difficulty, status, subscription type. This is the one I was looking for. Free only. So if you're curious for how many rooms are there that are free on Track, can we just do like a tiny bit and not learn anything? But you see all of these here are free. And there are 50 pages of 12 rooms that are free. So this is a great way to get started learning stuff. There's also a lot of things on YouTube, but I feel like when I started, I watched one video and then I watched another, and they were like 90% was the same information, right? And if you already know Linux and you already know networking fundamentals, yeah. So you could kind of check into stuff here, but as I said, run Kali Linux, test all the tools. So if we go to Kali, and we go, I think there's like a tools. So here we can see all the tools. So let's start checking out some of the tools. So do you know Nmap? Do you know GoBuster? Hydra? These are actually like, are they sorted on popularity here? Netcat, Netcat and Nmap and GoBuster and Hydra. These are real good ones to get started with. Wireshark to check out traffic. That's a graphical tool. So make a virtual machine or put it on an old laptop or something, whatever you can do. This is for exploring Wi-Fi's. Yeah. So you can just go through. Let's click Nmap. I don't know if you already know Nmap, but you can scan machines, for example. See what ports are open on the machine in a million different ways and different levels.
THNKX ribbon.
Yeah.
Sad face.
So, sad page. Hope I didn't make you sad. Also, there's of course YouTube. There's just Google. There's so many things. Currently, I'm looking at the pwntools here for Python. If you don't know programming, check out Python. It's very easy and simple and logical. I'm actually good. I've started making a course in Python. So I guess I'll add pwntools to that too. Yeah. So I think we have more processes. Core file. 2 core files. Let's close that one. It is from yesterday. I got a pay parking thingy, like 2 months after I parked. Please. So, sponsor new process. This is what we use to start the processes that we get the core files from.
I know Python didn't create any projects on it.
Nice. Then you have another piece of the puzzle, you know? And if you know Python, then you know how programming works, the basic structures, all of those things. So you're already started a bit, you know. So it's just to continue learning more. Also on Try Hack Me there's learning rooms and there are challenges. So we're currently doing a machine here that's called BrainPan. That's actually in one of the paths it's on buffer overflow section. And you can start machines and then you can check them out with Nmap to start with, and then you can maybe it has a web page that you can look at, and you can start looking at these machines and hacking them. So it's a great way to get started just testing stuff. And if you're not paying, you can still do this with, I think it's Attack Box. I don't know anymore, because I've had it for more than a year, so I don't remember if...
Thanks, smiley face. Translated from Tagalog.
Yeah, so I don't remember if you can use VPN, but the VPN is very nice and you can use your own Kali machine to connect instead of using their odd Attack Box or Kali. Yeah, here. The web. Those it's very messy to copy stuff with these. That's so slower, right? And usually you have stuff to fill in here.
New follower Honey to Hand War.
Thank you for the
Less
follow.
than 3.
And good luck with your studies. I usually stream quite a lot, so. And when I'm not online, there is something called like streams. So here you can see, oh, I'm currently offline, it thinks. It's a bit buggy sometimes. But then you can see a lot of people streams. So I think this is a French, so I don't speak French. Or might be another language I don't speak. Then we have GoPro, we have Theo, Shy Hat. So all of these people, they stream cybersecurity. Kira streamed a lot yesterday, I think. Pebble, yeah. So we have a lot of people here that stream cybersecurity. And all on different levels, different themes. Like Cerberus does, like here, she streams very low level stuff, very like cool things that I don't understand. Pwn College is an actual college, and you can go into there. So let's hop over there for a sec. That might be a good start too. It's free. Oh, Kira's on. So I think the website is a bit.
Alright.
Yeah, so this is an actual college. I thought they'd have links to their website. Yeah. So you can go into this pwn.college and you can register and log in and do their courses for free. And they also have a Discord, but I think you can't really be there. There's like special groups in the Discord that I don't think you can join if you're just doing this. But you can check it out. And this is more. Yeah, I think it's kind of all kinds of things, but it's. I should go back and check that out more too. So. I'm looking for the core dump file format. And I didn't find anything when Googling. Then we go ChatGPT on it. So we last time we did the DeepSeek to test it out for the second time. Now we're gonna do please explain the Linux core file format, and I can spell Linux. Linux core file format is a memory dump of crashed processes, typically generated when a program encounters a fatal error, segmentation fault. It is in ELF format and it contains process state information, including memory mappings, registries, stack traces, and shared libraries. Debuggers like DDB use core dumps to analyze the crash and determine the cause. I want all the details, please. Better say please. You never know what happens in the future. So, did it die on me? It happens quite often. The Linux core dump file format provides a snapshot of a process memory and execution state at the time of crash, stored in an ELF file. It's used primarily for post-mortem debugging with tools like GDB. Core dump generation. Core dump is triggered when a process... Well, we already know this. I want the format. Let's like update the page. Regenerate. Yeah, so now we're actually getting the right thing to what I wanted. ELF header. So we saw it said ELF 33 in there, right? Program headers. Describe memory region dumped from the process. So there's information in there about the memory. Node segments, PT node. Store metadata such as process register, signal information, and auxiliary vector. Memory segments, PD load, contain raw memory regions including stack, heap, and mapped shared libraries. Specify file type. Defines target architecture and byte order. These are what we are getting via Python here. So we got also the registers, we also got segments, right? Well, something called segments. Node segments. Containing important information about the process, general purpose register state, floating point registers, signal that caused the crash, and that's what we just got now, right? Sort of vector, runtime, environment info, list of mapped files, and process status. Okay, so process status too. Memory segments represent actual memory mappings of the process, include stack, heap, text, shared libraries, core dump configuration. And we're getting this information here. Right. So analyzing core dumps. So I'm thinking that a lot of this is interesting enough to put in my notes. And as this is not anyone's original texts, I'm just gonna copy it and I'm gonna say like from ChatGPT, make prettier in some way later, right? So this was a great what I was looking for in a short way. So good job, ChatGPT, on the second try. Or third. I guess. ChatGPT. So it missed the rest of the copy here. That's happened before. I don't know why it does that. So if I copy this, yeah, it failed. So we're gonna copy, paste. So because this was interesting, right? So So I will change that, make it better and stuff later. To fix and expand. Though it used to seem command ended in here. No, it was on the first part then. It might have been in the bit that got deleted. So we had a ChatGPT here before. Let's actually check this out. This is what we did last stream, I think, or even before that. Core read SP. Let's check this one out. Context binary. Yeah, because it's called binary. Oh my god. The binary is called binary. I gave it some of my code and asked it about something, so it's like it knew I had something called binary, whatever. IO receive until. That's not nice. Expected all bytes dumped memory. Dump memory. Is this which does read SP256. Yeah, that's not pretty. That's not pretty. Nah, this is bad. So closing a few tabs here. Let's see if there's anything more we want in this one. And then we're going to just continue with actual towards the goal. We went on a big enough. Yeah, especially since I have like 20-30 minutes left of stream. I need to go. I'm gonna drive my kid to school. I need to refill the car too. It's almost out of gas. And we leave in 50 minutes earlier from this week, so instead of 1:45, it goes 2 hours in school now. I said hard time in school. Receive repeat 0.1. Yeah, so we're not using this currently. We did this before with the send lines and stuff. Oh, with the context locate or local rather is false. cat prox of maps. So this is just a catting file. And then we're receiving the text. Okay. If you scroll enough, you find stuff. So, what is this? Looky. We found the gold. We need to go there. Address mapping. Returns a mapping of a specified address. So, let's see, did I miss anything else? It's mega interesting here from scrolling too far or something. No, that's just the main stuff. And then we have a lot of underscore. And this is the first actual address mapping. Oh my god. I just read this and I was like, so so I also noticed that these two have car in them instead of IO car files. I want the full name, not some variable example created. Let's just make it easier to read. There. Oh. Send land meow. Receive land meow. So it speaks cat. That's just a funny detail, you know. If they have to get an example and they use cat and they say meow. Good quality. A big approved stamp there. Should I run it? Also, I might replace my IO to P because we're not really using IO, right? This is just my variable name, and they have P instead. So let's do we want this in here? Yeah. Do we? It's not like we're gonna put the whole core file of 2 megabytes of data into our notes, right? To update where we were. And I don't think this is actually the saved version. So here, let's replace IO with let's do P here, and then we do IO with replace with P dot, because I don't want to replace other words like, no, that's still one. Yeah. Replace. So P is much more logical for something called process than IO. This is a separate one. But I do like P for these two. So let's do manually there, and then let's replace the one it's at. And then we have another we need to do manually. And then we replace that one, and that one, and that one. And then we don't have any more IO dots. So, as we made quite a big change with replacing the variable name, let's just run it and see that everything works fine. There. And we saw that we only got one line now. Because the program was actually updated. Yeah, so we have an exit here, but there's also an exit here. So this is the current test place. So this is for us outputting. We can get any data we want from here. We know this now. We can also replace the nodes and put P in here instead. Because I got this, you know, from the code example below, which I liked more than my previous one. And let's kill that thing. So the testing is done. This is currently the SP, ESP, plus the address length. Address length. So, oh, I get it. Number of characters in an address, of course, which is 4. So we need to add that to get to the data that is after, because that is where we have our use chars, which is our test for bad chars. So the characters to use in our bad chars test, excluding already bad chars we know about, right? Though the test when I did this last, I didn't have a good. I just added this, by the way, so it was wrong. So let's now see. We have P core file SP to print this, and that's not in our notes. So why not add? Let's add this to the notes too. And so we just made this note now, right? So it's just growing. So stack pointer at crash, and I will hopefully be after just popping off the last EIP, meaning the data we sent after the address, after this data, the crash amount plus the EIP, and then should crash, and the next amount of data should be our test data. So P core file SP is, and then we write the whole core file data. No, I'm doing that because let's do a colon here too, because I'm printing this afterwards. That's why. Let's actually extract that out. So it is a bit not prettily written, right? So this actually belongs with this print. and we can have a new line there. It's okay. When it does it automatically, I don't like it. So now when we output this, on the squigglies, it's a little bit buggy, definitely. And this is not a big print out of that. And we're gonna add a loop so that this is looped until there are no more bad characters, right? We need to add that. So it will not crash if the string has an F. So it's a manually definitely added bad char. And we know this from reading the code. So this is wrong. So here is the SP. We don't really need to print this. This is just for debugging sake. And then we're getting much more data than we want. This number should be around 256 as a max, you know, it shouldn't be more. So let's print it. Use chars. Yeah, let's print len use chars. And so we're printing the length of the use chars. So it's 254. So why are we getting this amount of data here? It shouldn't read more. Core file SP. Oh, I'm actually doing 1,000 here. So why do we have two of them? Stack data and data. I was testing stuff. Okay. So P core file plus address, and I was just testing more about what can we get. And for some reason I'm printing data, not stack data. So let's actually make this stack data. Because stack data is a better variable name. And then we get rid of this. And then we have a much more reasonable there. Get the data from stack position in the dump. Not a good comment. From the stack pointer for length of use chars. And we don't really need that comment then because it's just the same as the code. That's it. So temp, why am I printing temp? Because I want to compare. Then we run that as an argument. So why call it temp when it's the argument? Or parameter. But argument is okay. Parameter sounds odd. So I'm doing argument. This is good enough. It's better than temp. I was like thinking I didn't find a good name, so let's do temp, right? To get good, to not get stopped by it. So, actually, yeah, exactly what I was going to do, clear. So we have fresh, new. So let's actually scroll up to the start of testing for byte characters here. So first, we're printing something here. Oh yeah. Yeah, I can see this is the non-repeating string. Yeah. So temp is longer than this, and this is actual use chars. So from the top, testing for byte characters here, we have we're printing the actual use chars. We don't need to. So let's comment that. Then we're setting the argument, and we're printing the argument. And that is kind of useful right now. Or not. Let's just read it. So, yeah, it actually says temp here, meaning we didn't save the file before we run it. So we have to redo. Clear, run. And now I removed test, right? So we're just getting random data up until the 42s, 4 42s, which is the address. And then we have our bad character test all the way until here. And this should be 254 characters because we removed null and we removed f. So the length is correct. Then this is nothing we need to print, so let's remove the sp print. This was just me being curious there if it worked when we started. Then we have the core file. Also, we had an extra new line there because we had them on the same line first. So here we can see the data as it's read from memory, and we could manually check this, but this is the next step. Are there any bad characters? And we can see that there are not, right? So let's add back null and see what happens if we do that. Also, do we want any more removed? Let's remove argument printout. And let's rerun it just to see as we have a comparing there. So the core file looks like that. And that's reasonable to have that with us, you know. Actually, p core file at, that was a very bad at core file dot sp plus 4. By the way, I realized why I didn't work the other day when I was doing these bird wings. So now it's correct. We could add p dot here too. This is more like a debugging comment. Oh, I mistyped at stack pointer. Let's write it out. Core file contents at stack pointer. Where's this? Oh, right. Position. No, I guess plus 4. We'll see. Yeah, so time flies, and it's already 21 past. I saw that Kira was online, right? We have to run it. And let's try and remove null. And I don't know how much anything will work. I'm guessing it will all be bad if we do. But it's a good bug test to see if the code is mega broken, right? If we remove this, the null from the bad chars. Now this should be like not working very good. Executable argument, inline init, validate, normalize args, message. Not enough argument for format string. So it is an empty string now, meaning it's nothing, and not even that works. We can't even send an empty comma nothing, you know, that's what it becomes. So argument is empty. So for this executable, we don't have a good test. If we do F, it won't crash. So, but let's test that. Come on, I'm trying to click you. So, oh, it did crash. So error could not find core file. Yeah, because it didn't crash. So it couldn't find the core file because it didn't actually crash. Because it's using 255 characters, but the first one is null, the terminal is a string, setting it all to 0. So it's actually 0 length. So that's why we need. No, sorry. What happens is in the executable. I'm sorry for the last thing. I was messing it up with the nulls. So let me show you code quickly before we raid. This is what the program looks like, and the string copy that we're exploiting, it is not entered into if we have an F. So this is an infinite loop that increases 1 every lap, and if it finds an F, it will break. So it will never copy if there's an F, because it only does the copy when we're at the length, the end of the string. So it finds an F before the end of the string, it will not crash because it will not run this function. So that's why we can't have an F in there, because it breaks the whole buffer overflow. It won't overflow. We never reach the vulnerable function. Yeah. Can you please with this? I'm sure it will work on another executable. It's too bad there weren't any bad cars, right? I didn't find any more bad chars. It's all in memory as it's supposed to be. So let's run it once more. Let's clear it again. Run it. Program crashed at 120 characters. As long as there are no uppercase F's in there. So that's nice of them not to break our thing by using lowercase f's, because it would have broken my script. Here's the crash. We get this programmatically out. We find the position of it. We generate shellcode. We test for bad characters. And the next step that is actually already finished. Right, we didn't add the loop yet. We're going to have to add a loop. And I won't have time for that now, but let's hop over to the code anyway. So we already have here code for removing the bad chars from by encoding it, the payload. So we have generated the payload, and when we encode it, we tell it not to use the bad chars. So the bad chars that we have from here, we're going to add the bad cars that we found to this. But we'll have to be a bit smart too, right? Let's just add the first of the bad car. So, because it might be like buggy. So add the first of the bad chars to bad chars. First of the new bad chars to bad chars. Right. Let's make this code, but pseudocode. So if bad chars new bad chars, and we're in Python, so we do not. I guess we do length, and it's quickly becoming Python code. If not len new bad chars equals 0. Add the first of the new bad chars to bad chars. Loop the whole darn thing. Right? That's nice code. And we'll be looping from the generation of the bad chars here. So we need this in the loop. Loop. And time is flying by, and I need to go. So let's get a quick look at the current streamer status. Who's streaming? No one's on InfoSec stream, so it's obviously not. Maybe GoPro's updating it again. Oh my god, this was loud. Sorry for the echo. Echo. I saw Curious X online. I'm gonna raid him. No pretty stuff here. I'm just quickly gonna raid. So, thank you for being here. And we raid in. So when I'm done with my kids been at school and stuff, I won't have any time anymore I won't have any time to stream more today. So tomorrow, I'll stream tomorrow at like 13ish my time. So thank you again for being here, and have a great day, and bye-bye. Be clicking the raid button.